everybody, it's Mrs. Pound, and we're moving along in chapter 1.4 about chemical interactions. And yesterday we talked about chemical bonds in general. Today we're going to focus in on covalent bonds in section 143. So our objectives are to describe covalent bonds, interpret the tendency of different atoms to form polar bonds, and compare polar covalent and non-polar covalent molecules. Covalent bond is the type of bond in which valence electrons are shared between atoms, just like these two children sharing an umbrella. Covalent bonds tend to develop when electrons are shared between two nonmetals, so two nonmetals. We have what are called diatomic molecules. These are a molecule made of two atoms of the same element. Some examples are H2, O2, N2, and Cl2. These are always found in nature as diatomic molecules. You will never find them as just single atoms naturally. Larger atoms have a weaker electron attraction. You need to know this. Think of an atom. Here's the nucleus, and we have electrons going outward. The farther they go outward, the farther they are from the nucleus, the less attraction they have for the nucleus, because they're, number one, farther out, and number two, they're also shielded by the electrons that are in the middle. Think of this like gravity, perhaps. The farther you get from Earth, the weaker the gravity. So the farther an electron is away from the nucleus, the weaker the attraction. Also think of magnets. Close together, the magnets are really strong and stick together. As you go farther and farther away, the attraction becomes weaker. There are two types of covalent molecules. There are polar and nonpolar. And a nonpolar molecule is a molecule with an equal charge distribution. There are no partial charges, and there's equal sharing of electrons. This is the key part, the equal sharing of electrons. So some examples, and it has a lot to do with symmetry, are methane. A carbon in the middle, and the H's, the hydrogens, balance out with equal pull. Carbon dioxide, carbon in the middle, oxygen on each side. It is what we call a linear molecule. So those oxygens actually pull on the electrons a little bit more, but it's an equal pull. It's kind of like tug of war in a line where they have equal pull. The same thing, all diatomic molecules are nonpolar because they have equal pull. It's as if you had identical twins with the same strength in a tug of war match. Polar molecules are a molecule with a balanced charge that is not equally distributed. One end of the molecule has a partial positive charge, the other end has a partial negative charge. There is unequal sharing of electrons. An example is water. Now when you look at it, you're like, well, shouldn't that just be like carbon dioxide? But what I know about this is water has a bent configuration. It's not straight, it's not linear. Oxygen pulls on the electrons a little more than the hydrogens, so there is a slight negative charge up here. This funny letter here, that is a lowercase delta. So it just means that there's a charge difference that makes that negative. Down here, the hydrogens are partially positive. So this is a polar molecule. It has poles. It has a negative and a positive pole, kind of like a battery, or like a magnet that has north and south poles. And so that makes it polar because of this charge difference, because it's not in a straight line. So our objectives were to describe covalent bonds, the fact that they share electrons, interpret the tendency of different atoms to form polar molecules, and to compare polar covalent and nonpolar covalent molecules. So don't forget your 5 questions.